Welcome to the factoring review video. The purpose of this video is just to go back and talk about factoring that you learned previously in Integrated 2 or maybe even before then. So let's go ahead and jump right in. So the big things really that you need to focus on for this review are the GCF or greatest common factor, which we know if there is anything that all of the terms have in common, it makes your life so much easier if you factor that out in the beginning. Then we've got the boxes and the diamonds that would go along with trinomials, and then the pattern of difference of squares, which I believe you guys were introduced to back in Integrated 2. So let's go ahead and jump right in. So in question number 1, I noticed that this is a trinomial. There's 3 terms. First thing I always do is check to see if they're a GCF, and there isn't. The only thing that you could divide out of all 3 of these is a 1, but dividing by 1 doesn't really do us any good. So I want to make sure that it's in order. I would like it in descending order of a single variable. So if there were multiple variables in here, I would choose one of the variables to put it in descending order of. So in this case, it's already in descending order. All right, so since it is a trinomial, no GCF, which I would have handled originally, I'm going to go ahead and draw my box. Now, using the generic rectangle and the diamond, those are just tools. So if they help you, great. If they are unnecessary for you, then you don't have to use them. They're just supposed to help you. Okay, so the diamond, remember we would multiply those 2 things that we just put into the box. That goes on the top. When we go back to the original question, and the middle term, in this case the linear term, would go in the bottom. All right, so we want to multiply to get to the thing on the top, and we want to add to get the thing on the bottom. So this one's fairly obvious. That's 3x and 2x. Those 2 guys go into the empty 2 boxes. It doesn't matter which one goes where. And then you want to make sure that you factor out. So I'm going to take a look at the different columns and the different rows. So I'm going to look down here first, and I notice that I can take an x out of those. So I'll pull an x down here. Okay, then I'm going to look at those. I see that I can take a 2 out of those. Oops, so I'll put a plus 2 down there. Then I'll go through and do the sides. So I can get an x out of both of those, and then again across the top I can get a 3 out of both of those. So the factorization that I'm going to have, so what you have here with the x squared plus 5x plus 6 is something that's in standard form, or multiplied out, I think is the best way to put it. It's written as a sum. Then we could write this in an equivalent fashion so that it is written as a product. So x plus 2 needs to be one of the factors, and x plus 3 needs to be the other factors. Don't solve. You're not solving right now. We're just factoring. Okay, let's move on to question number 2. First thing, GCF, yeah, I do. I'm going to go ahead and take out the 3 that each one of them I can divide out of evenly. So I'll have a 2n squared plus n and then minus 10. Now I have this new thing that I created, this 2n squared plus n minus 10. When you're factoring, you have to keep going until you can't factor anymore. So 2n squared plus n minus 10 is a trinomial. Chances are I can probably factor it. So I'll take out the boxes. And then don't forget about that GCF of 3. You're going to put it back in front of the answer when you're done. So it doesn't really come into play right now. Okay, so it's kind of setting up what we would have done previously last year. Multiply to get the top, add to get the bottom. I think this is a 5n and a negative 4n. Again, put them into the 2 empty boxes. And then let's go through and take a look at those. So I think I take an n out of that. So let's put an n down here. Then I think I can take a negative 2 out of that. So let's put a negative 2 here. Now I'll take a look at the sides. I can take a 2n out of that. And then it looks like a plus 5 can come out of that. One of the other things too you really might want to consider, is pretty important, when you go through and you do this factorization, do a quick double check at the very end and make sure that the length and the width of each box actually gives you, so multiplied together actually gives you the stuff inside that box. All right, so now I can go back to the original problem, so I'm just rewriting it now. And don't forget about that GCF of 3 that you took out, so we're going to put that 3 right in front. So I'll put the 3 there, just kind of carrying it with you, and then take your parentheses. So I had an n minus 2, and then I also had a 2n plus 5. And then that's my new factorization. Again, I'm still double checking, looking inside. Is there anything else I can do to factor? No, I can't. Okay. Moving on, question number 3. So it's still a trinomial, but I wanted to give you something that had some more variables in it. So something you might want to, you're definitely going to encounter. Additionally, I made sure that we had a coefficient that was a leading coefficient that was negative. So let's take a look about the order first. So first and foremost, I want to make sure that I chose a variable and I wrote it in descending order for that variable. So you'll notice that there are x's and y's here. I chose x's to descend. So my first one that I have here is an x squared. Notice that that is the biggest x in here. Then my next term went down to an x, and then my last term went down to no x at all. So my x's are descending. While this is happening, chances are your y's are going to be ascending. So no y to begin with, then a single y, and then a y squared. It's kind of like this balancing act that happens with the different variables. Okay, so I'm confident with the way that it is set up. I really don't like having a negative in front of my 12x squared. So I'm going to factor out a -1. So if I take the negative out, what it's going to do is flip the signs on all of these. But then when I'm factoring, it should make my life a little bit easier for factoring. Plus, I'm thinking kind of down the road. So in future classes, I'm definitely going to want to factor out that negative sign. It'll make polynomials and pre-calculus much, much, much easier. Okay, so now to trinomial, I've got a 12, a 28, and a 15. There's no GCF there. I mean, it kind of looks like it on first glance, but there isn't. And then none of them have the exact same variable that I could pull out. So 2 of them have x's, 2 of them has y's, but not all of them have one of those things. So at this point, I'm now just looking at the trinomial. Let's go ahead and draw your box. And then remember, just like I said, boxes and diamonds are just a tool. So if you don't feel like you need to use them, don't use them. If you find yourself making mistakes without them, then you need to use them. Okay, so I'm going to multiply the 12 and the 15 to figure out what goes on top, and I think that that gives me 180. And then don't forget the variables. So x squared, y squared. It'll make your life a little bit easier when you figure out what the two sides are supposed to be. And then the term in the middle is going to be that -28, and it is an xy. All right, so the only way that you're going to multiply to get the top and add to get the bottom is, well, with the addition part, they have to be like terms, so they have to both be xy, xy. So I'll fill the numbers in just a second. And then do a quick check and make sure that if you multiply xy and xy, you actually get the x squared, y squared on top, which you do. Okay, so this one really isn't too bad. I know it looks like, oh no, it's big numbers. Well, it's not terrible. It's actually -18 and a -10. So if we multiply -18 and -10, we're going to get a positive 180. If we add -18 and -10, we get -28. Okay, put those guys into the empty boxes. So we have our -18xy. Don't forget the variables. Make sure you take them with you. And -10xy. Okay, now we're taking a look at the different columns and rows. So in this case, it looks like I can take out a 6x. So I'm going to take a 6x out here and put it at the bottom. Okay, then we'll take a look at the next one. It's going to be a 5y, probably a negative though. So I'm going to make this a -5y, and then again, as I'm checking to make sure that my stuff works, double check your signs as well. Okay, so if I look there, I think that's going to be a 2x, and I do want it to be a positive 2x because I want to make sure that my 6x and my -5y work on the bottom. And then across the top, it looks like that's going to be a 3y, and I think it's going to have to be a -3y to actually get it to work. So -3y. Okay, so got my factorization. Let's go back up. It's going to be a little tight up there, so I'm going to put it down here at the bottom. So my factorization, don't forget that negative sign that was out in front. So remember that GCF we took out. Make sure you put that GCF back in front. And then my factorization, well, I got a 6x minus 5y across the bottom, and then up the side it looks like I got a 2x minus 3y. Do a quick check, make sure that those can't be factored. They can't. The only thing that you have out of each of them that you could take out is a 1. Dividing by 1 doesn't do you any good. Okay, question number 4. Question number 4 is just like question number 3. So I did the balancing with the variables again. Notice that I'm descending in x's. I could have descended in y's. It's totally fine. But you do kind of want that one going down, one coming up at the exact same time. Looking for a GCF, and I think it's going to be, well, on first glance, I thought it was going to be a 6. But then when I looked at it, if I divided by 6, I'd get a 6 for the first guy, a 10, and then a -4. Okay, so 6 isn't it. It's got to be bigger. So if you take a look at it, you can take a 2 out of each one of those as well. So you would take out a 6 and a 2. That's a product. You're actually going to take out a 12. So I'm going to take out a 12, and then if I take a look at this very first, like 36, and not just the 3, but the 36x to the 4th, that's positive. I'm not going to take out a negative number like I did on the previous one, because there's nothing wrong with it right now. So I'm going to take the 12 out, and then this is going to give me a 3x to the 4th, plus, that gives me a 5x squared y squared, and then minus 2y to the 4th. So now, since this question is just like the previous one, now would be a great time to pause it and see if you can do the problem. If not, I'm going to go ahead and talk my way through it as well. But if you want to give it a shot, pause now. Okay, for the rest of you guys that are still with me, I'm going to go ahead and I'm going to make a box and diamond for the trinomial. So I've got a 3x to the 4th, a -2y to the 4th. Okay, put that inside here. So that's going to give me a -6 x to the 4th, y to the 4th, and the middle term is that positive 5x squared y squared. Okay, again, the only way to get the addition in the bottom is if the variables are the same. So x squared y squared. Do a quick check. If you multiply those, do you get x to the 4th, y to the 4th? Yeah, we do. All right, so we want to multiply to get the top now. All right, so I think the only way that we're going to multiply to get the top is with a 6 and a 1, but then I want to get a -6 but a +5 when I add. Okay, so it's going to be a positive 6x squared y squared minus 1x squared y squared. So go ahead and put those guys in to the empty boxes. Remember, it doesn't matter which one goes where. And then go through and factor. All right, let's take a look here. So I think it's going to be a 3x squared for that one. And then let's take a look at the next one. So that's going to be a negative y squared. All right, let's take a look at the bottom row. It's going to be an x squared, and then do a quick check and make sure that the x squared actually works for you based off of what you already put across the bottom, which it does. Then take a look here. So it looks like it's going to be a 2y squared, and a 2y squared does satisfy and make sure that the other ones work as well. Okay, so kind of run out of space here, so I'm just going to put it at the bottom again. Don't forget about that 12 out in front. So remember to take your GCF with you. That's important. So there's my 12 that I took out, and then a 3x squared minus y squared across the bottom, and then an x squared plus 2y squared up the side. Okay, taking a look at it real quickly, there's nothing else that I can do with these factors. Close. The first one, the 3x squared minus y squared, is very close, but not quite. All right, moving on. Okay, now we're back on to the difference of squares that you guys did previously. So as you know, or not, I guess it kind of depends on who your previous teacher was, you can actually treat this as a trinomial if you would like, but it's not necessary at all. So I'll show you what I mean by treating it as a trinomial, and then I'm just going to use the pattern. So if you have your x squared minus 9, you can actually rewrite it as x squared plus 0x minus 9. Now you can go back to the techniques that we did previously. So you could do the boxes, then you could do the diamonds, you could figure out what goes into everything. Once all is said and done, you would have ended up with x plus 3 and x minus 3. If you're not sure, pause it, test it out yourself. There's a pattern, though, to this, which is really kind of nice. So if we take a look at the original question, the first thing we want to look for is how many terms do we have? Well, we have 2, so it's not technically a trinomial unless we put the 0x inside. The second thing that I want to look at is the sign between them addition or subtraction? I want that sign to be subtraction. If it is subtraction, I can proceed. If it is addition, I'm going to kind of put the brakes on and go, uh-oh, what can I do now? Then, after identifying that it is subtraction, I take a look at each one of the terms separate from each other. And I ask myself, could I square root those 2 terms? Easily. I don't want any funkiness happening. So, like, I don't want to have to square root 5. That doesn't do me any good. I want to be able to square root, like, 9 or 25 or 36, 121, stuff that can actually square root down into something nice. If the answer to those questions is yes, then we can go ahead and go straight to the punch on this. So what we're going to do is we're going to take a look at the very first term. I'm going to look here and we're going to square root that term. Well, the square root of that term is x. Now, I'm going to open a set of parentheses. I'm going to put the square root inside. But I'm going to open another set of parentheses and put the square root inside. So those two multiplied together gives me the x squared that I started off with in the first place. Okay, so now I've already decided that I can square root both of the terms. So now I'm going to look at the next one. Then I'm going to square root the 9. Notice it comes second, so I'm putting it as the second thing inside the parentheses. But I'm going to put it as the second thing in both sets of parentheses. Close the parentheses. Okay, I'm in the home stretch. Now, last thing that we need to be able to do. I want the last two things that I just put in, the 3 and 3, so that when I multiply them, gives me that -9 that I'm looking for, or -9. The only way that's going to happen is if the signs are different. So one of these is a plus, the other one is a minus. That's your answer. You get the exact same thing if you went through and used your diamonds and boxes. But this is a pretty slick little pattern. Again, it's got to be, can you square root each one of the terms separately? You got to have a subtraction sign between them. And I think that's it. You need to be able to square root them and you got to have a subtraction sign. Okay, let's move on to question number 6. Question number 6, I'm not thrilled about with this one originally because I see a minus sign, which is really nice. I feel good about that, but I really don't like that it comes first. So I'm going to proceed the way that I did previously on the trinomials that I did. I'm going to look for a GCF. So, and I don't want the leading coefficient to be negative. I'm going to get rid of that negative. Well, pull it out. I'm not going to get rid of it. So I'm going to factor out a negative, and then with the 72 and the 2, I can take out a 2. So right now it doesn't look like there's much I can do, but I can. So I'm going to go ahead and divide. That's going to give me a 36x to the 4th minus 1. Now reassess the situation. So look at everything inside. Trinomial? No, not at all. Binomial, so 2 terms, yes, absolutely. So now I'm going to ask myself about the pieces. Can I square root each of those pieces and get a nice answer? So if I take a look at the first one, can I square root 36x to the 4th? Yeah, I can. It's 6x squared. Then I ask myself the exact same question about the 1. Can I square root 1? Yeah, I can. This is good. Last thing. Is that a minus sign? Yes, it is. All right, let's go. So I'm going to go straight to the next set of parentheses. Don't forget that GCF. Bring it with you. So if I square root the 36x to the 4th, that's going to give me a 6x squared. It was the first thing, so put it first in both sets of parentheses. Okay, now let's take a look at the next one. The second thing is a 1, so the square root of 1 is going to go second, but it goes second in both sets of parentheses. Close that parenthesis. Then the only way you're going to get this -1 that you're trying to get when you multiply is if the signs on your 1s are opposite of each other. So give 1 a plus, give 1 a minus. Do a quick check. Can those be factored any further? No. The second set of parentheses maybe kind of looks like another difference of squares, but it's the 6 that blows it. Like I only want to square root stuff and get stuff that's nice. I don't want to do like square root of 6 and square root of 6. That's unpleasant. Okay, and then the last question here, 7, just like the previous ones. All right, so I'm going to take out a GCF, and I really don't like the thing in front to be negative, so I'm going to factor out that negative sign. And then I can take a k squared out of both of these guys. Okay, so that's going to give me a k squared minus 9. I ask myself, is that something that I can factor? Yes, it is. Absolutely. So bring down my GCF with me. The square root of the first one is going to go in first into both sets of parentheses. So square root of k squared is k. Then the square root of the second one is 9, and that one's going to go in second, so the square root of that's going to be 3. Close the parentheses. Man, oh man, that better be a minus sign. If it's a plus, you can't do this. It's not possible. So it is a minus. This is good. 1 gets a plus. 1 gets a minus. Do a quick check. Take a look. See if there's anything else that I can do to factor this. And I don't think that I can. Hopefully this review has helped.